So today there's some things I will be covering. These are actually parts of the webinar exactly. Um, so instead of reading them off, they're going to kind of flow pretty quickly as we go. There's a lot to cover, so I don't really want to spend a lot of time reading through all these items, knowing that they're going to come up next. So I do have one question for you, if you could help me with your polls or responding. What type of blower door test do you do besides the standard residential blower door tests? Which means, are you doing any large building would be one option, multifamily, um, any other tests in terms of maybe testing windows for the water test. There's an enormous amount of tests that are out there, which if you are doing something besides residential, you would actually be very aware of that and can chime in and let us know what are some of your multi-fan that you're doing. Or if you're not, that's okay. It's your chance to again, chime in for your credits and let us know if there's something else you're doing.
Well,
So,
while you're on that topic,
yeah.
something we discussed earlier is the reason why we're asking these questions is also to understand who our audience is and orient our answers more towards the audience as opposed to what we're guessing the audience is.
Guessing is never good. So these are your standard gauges. So my next two questions are for you is what type of gauge do you have? You may respond with multiple, whether you have a DG700, DM2, or DM32. Wi-Fi or not doesn't really matter. This also helps me in terms of my discussion and some of the concepts we'll go through. And the next one would also be what kind of fan do you own? Do you own, and I have some examples of what those are coming up if you're not sure what your fan is. So this is a common question that we get during the webinar, so I made a slide for it. Support gets a lot of questions about it. You can actually do this actually online under the support page, but there is a significant buyback program in terms of whatever older gauge you may have. So if there is something you did, Colin mentioned this a second ago, if there is something that you wanted to cover today that you may not have saw on the slide about what we're going to do today, or just something to make sure that you reiterated it, please don't hesitate to chime in. Colin's reading some of your responses. Somebody says the polls don't show for me. The polls aren't there, actually. I'm sorry. They're kind of broken today. I don't know why they're not working, but the polls I'm going to just kind of do as a verbal, and if you could just respond in the questions panel would be perfectly fine for everybody. Again, if there's something else you want to make sure we cover today, we'll read through those as we go, and Colin's in the background making sure that we touch base on any of your goals for this afternoon, or it could be this morning, depending on where you're at. I do have a quick overview. Again, this is like a multi-fan 101, so I should put some fans on there to kind of describe what fan you may have, or how you use your fans, or how powerful they are. A lot of people own the 1000. I talk to a lot of people when I travel, and they still own the 2000s. That's my first fan that I bought, and actually a Q46 it was called. One of the things that you can distinguish your fan is based on the shell, whether it's a single ply type of material over in the right hand corner, or if it actually was the injected motor with a foam filled core, a little heavier fan, or whether it also may have an actual external power supply, which goes from single phase to three phase. So those are kind of things that differentiate between the 1000 or the 3000, which are the kind of common models for the last several years. The 2000 has been faded out. So all that has been changed recently when they modified how the ranges and the rings work. So now things are all on the single lighter weight shell, incredibly durable and flexible. And now it's called the 5000 or 6000 series. And that number changes slightly depending on what kind of frame you may have. So if you bought a blower door in the last several weeks, you would have received a 5000 model. And you can tell by the different plugs and the different ranges that are on there. In general, they both move about the same amount of air compared to the residential version versus a commercial version. So how many fans do I need is actually a question that comes across the support team weekly. And so there is actually a number of fans calculator that you can download on the support page. It's an Excel spreadsheet that asks you a few questions about mostly its surface area as a common question you need to know, but has some other alternatives and determines what kind of fans you're using, and then gives you an idea about how many fans you would need in order to complete that type of actual test. So it's very intuitive, very easy to follow, and user friendly. It is designed more for the 3-fan, 4-fan, and up higher in general. So that's kind of the use for it. Some other things I want to make sure we're on the same page about are the frames or some of your options about doing a multi-fan test. So recently Retrotech released the Passive House. They call it the Passive House frame, which is basically the window frame for the duct tester. And depending on how tight your home is or how small your unit is, that may do fine for doing a blower door test. It also can turn sideways, so it doesn't have to be vertical. The standard frame is in the middle. It does have some really cool pockets in the middle if you've not seen that. And this is the large frame. So it goes from 51 to 109 inches wide. So it does actually overcome some of those larger doors that you see. There's also an option of using a different door in the house. But if you have a challenge, Retrotech has been there to support whatever type of method you're doing. If you have not seen the hard panel, some people love these, some people hate them, and depends on what camp you're in. But these are an engineering marvel. If you have not seen these, we'll try and get one to the show when we go out to ACI or some of the larger shows. But this thing sets up in really a matter of seconds. It is a little large to carry around, but in terms of how it adjusts and stays reasonably airtight, it's not the tightest device to actually do that kind of test, but it's not an open door either. But it is really amazing, especially the center panel, which actually will adjust horizontal and vertical. So most people can set these fans up in a matter of 2 minutes or less. And now the hard panel was usually only designed for the commercial or the thicker framed fans. That's been changed. Now there actually is a panel that actually will work with the modular panel that will work with the 1,000 fans or the new 5,000, 6,000 fans. The one that's out there, which many people only seen actually in pictures, is the 3-fan folding panel. Now, if you are doing large building testing or multiple fans, this was a godsend when this actually came on the market. This really allowed you to do a phenomenal job of setting up the 3-fan stacked and actually supporting it well, and using your garage door openings or some of these larger scenarios to actually set up these kind of fans with a much more rigid and sturdy frame. So it folds. There's several supports they use on the outside to hold it in place, depending on which way you're testing. And the fans kind of just turn, push in, and they turn kind of counterclockwise to lock in place. So now we're going to get into some of the logistics, which is why the meat and potatoes of why people are here. So we're going to try to talk about control issues and challenges with setting up more than one fan. This could be more than one fan in a single location, or it could even be 2 fans that are on the other side of the house or the other side of the structure, or floors apart but are connected or not connected. So this was a test that was recently done. This is a passive house mall. That's right, a shopping mall. And I believe they had 24, 27 fans. I know Jay's dying to chime in here to kind of fill in the details, but they were able to test this mall to confirm that it complies with the passive house standards. This was not done in the U.S., obviously, and there's a video that we have online, and I think it's on YouTube, that shows all of these fans working to go through their test scenario, and they're jumping for joy at the end. So here's where the 2-fan scenario or the multi-fan dilemma comes into play, is that when I have 2 fans that are working in the same zone or trying to work on the same area, that what can happen is that one will just slightly over dominate the other, and next thing you know, the one fan is moving slower and slower, or has basically stopped, or is it working actually in reverse because the air just gets pulled back through it, right? So if I set both these gauges to 50 pascals and they both have a reference inside the house or inside the structure, depending on which way, where you're actually standing, whether you're outside or inside the structure. So they both reached slightly different pressures but began to battle each other. So we're going to talk about some of the ways you can set up what's referred to more of a common control. So if I have even just 3 fans in one doorway can actually be a challenge amongst themselves and one starts slowing down or going reverse. So this is the better way to do it. I have my 3 gauges, and I'm going to refer to the Ethernet connection. This is actually how my control signal will go back to a router. It goes back to my computer. a router and a hub may be combined, but that's just depends on how many connections you have. So this is how I get my signal back to the computer. I'm now able to control each gauge individually. Right now, whether or not each gauge is going to control a fan individually is what we're going to set up next. So we're going to have one gauge that will be the dominant gauge that will be reading and referring to the other gauges in this scenario. So I do have a control cable that's going from the top gauge over to the top fan. And then I'm actually now just going to connect the other fans, basically one into the other. So there's ports on the side for the Ethernet. And this is what allows the other two bottom fans to be working in the same manner with the top fan. So they're not going to be battling. They're all going to be kind of running in the same fashion with the same speed. I still will be connecting the tubing in order to read each fan. Pardon me. The illustration gets a little challenged, so I'll try and do those as separate illustrations. So this is really to illustrate the common control scenario, where basically one gauge is controlling multiple fans throughout its scenario here. And you can see that when they come on, they're all moving synchronous, and I'm able to get a solid reading. It doesn't actually interfere with one to the other. So what I have here is trying to also visualize from the side is that I am able to do a control where, again, both are moving the same amount of air. In theoretics, they're not exactly identical, but they're now able to move and not battle each other. Let's go through the same scenario where I have my connections back to the computer, but a common flaw that people will set up is they'll actually connect their gauges as though they normally might for a single fan, and realize that this actually will be a major challenge for them. That what happens is that the fans will begin to move, all rotate the same way, but then suddenly some of them will slow down, and actually some of them will begin to go in reverse. Right? And depending on how many fans you have or how far away they're at, if they're not necessarily right in your visual, this may be a challenge for you. There is for those who do large buildings, they'll actually walk around with their banks with a thermal image camera and go around and see which ones are not at the same temperature. Then I know that it's actually not moving or maybe moving the opposite direction. So this is actually the dilemma that can happen in a single setup or depending on how you set up your fans in the same structure. Yes, Colin?
Yeah, I just wanted to say that if you set your fans up this way, you can often get away with it, and it can work fine for many, many tests. And all of a sudden, you may not even discover the fact that one of your fans is stopped because the fan is still spinning, and you may get crazy results. But could you just go back to the previous picture where we showed that 3-story thing with the tube on the upper floor? I think it's like one slide back.
I think it's coming up actually.
Yeah, you just showed it, I think.
Yeah, I have other slides that complement this.
There we go. So if we take a look at what's going on here, if we're running 2 gauges or more, we typically want to pick up the pressure in multiple places in the building. So what we'll do here, fan number 1 is picking up the pressure in zone 1. Fan number 2 is picking up the pressure in zone 2. That's exactly what we would like. What happens there, though, is that fan number 1 is essentially satisfied a little bit earlier than fan number 2 because there's a pressure drop through the stairwell and whatnot. So what happens is that when fan number 1 gets the space to 50 pascals in zone 1, then fan number 2 is still seeing that its pressure at the top and the 3rd floor there is still maybe 45 pascals. So it says, I need to speed up. So it keeps speeding up. As it speeds up, the fan down below says, well, gee, I have more than enough airflow. I'll slow down. I'll slow down. If fan number 2 has sufficient capacity, it will take all the load and allow fan number 1 to stop. However, if fan number 2 does not have sufficient capacity, it may appear that this control scenario is working, and you may get away with it a couple of times. And this is why people who've done testing for many years using our fans will all of a sudden say, my God, the fans are fighting each other. Well, no, actually, they're doing exactly what you told them to do. It's just you haven't run across this circumstance exactly yet. So you're controlling fan number 2 by the pressure on the 3rd floor. you're controlling fan number 1 by the pressure on the first floor, but those pressures will be slightly different, and that's why the fans appear to be fighting each other. And in situations where all the pressure pickups for the same are in the same zone, you can often get away with this. But that's why, as Joe says, you have to be clear about what you're telling the fans to do. And by simply taking the control signal from fan number 1 and putting it into fan number 2, it means that both of those fans will be locked together, just like they were mechanically attached together almost. One goes up 1% speed, the other one goes up 1% speed. Okay, Joe, back to you.
Thank you. You'll be back, Colin. You'll be back. So again, that's our common scenario, our common connection, common control, and versus in our flow that actually will be very successful. Versus again, you may be tricking yourself or successful that this actually did work, and that realize that maybe 1 out of 10 you didn't realize that one of your fans was not moving in the scenario. And the worst case is that it could be moving backwards. Okay, so again, this is not your better setup. So, and here's one of the scenarios that also kind of illustrates that is that the flow driven by this fan actually becomes more dominant, and then there's just passive air that actually gets pulled back through the fan through the other one. So here's some other scenarios that talk about whether when I actually have a set of fans on the right side and a whole separate set of fans on the left. Notice that they're all connected. They're in their common control, right? Versus the next scenario where they're actually doing individual control. Colin, you'd like to comment on these 2 slides?
Carry on.
All right, great. Okay. So our goal was to try and find some illustrations that may have actually triggered or caught for you. So one of the things I'm going to talk next is about tubing. So any other comments about the wiring? We good? Great. So I will talk about some tubing as some of the things that happen, because it's, again, we're going a little more than residential, and some of the connections can be slightly different depending on where you're trying to get your pressures from in the structure. So,
Joe?
yes, sir.
I just wanted to make a comment based on a question. I'm sure if this person had it, other people do as well. The question is, so individual control is not recommended under any circumstances. Well, actually, the reverse is true. You should keep the current version of the software, when you take it off individual control, unbeknownst to me when I talked to our programmer last week about this, they said that when you take it off individual control, you get no control signal to the other fans at all. You only get a control signal to the primary or number 1 fan. So I would recommend just the reverse. Always have your software set on individual control, and then rewire your control signals so that the fans get the signal from fan number 1. Because once you disconnect the signal from the gauge, and you take the signal from fan number 1 and send it to fan number 2, it doesn't matter what gauge number 2 says. It's going to follow along. And that's why every one of our fans, you'll notice, except the ones we made like 10 years ago, have got 2 Ethernet ports on the fan. One is for signal in, the other is for signal out to daisy chain into the next fan. If you don't happen to have that, you can get what we call a splitter that will take the same signal and send it to as many as 12 or even 24 fans, so that every fan is getting the same instruction, which is go to a percent speed. Back to you.
Thank you. So what we talked about a minute ago was actually all the control cables that control the fans, or the signal from the gauge that goes back to the software, basically. Now, these are actually the tubing, because you still have to have tubing connected from each gauge to each fan in order for it to read the results, right? So this the 1000 fan has a single yellow port, or the 5000, or you could be using the commercial fans, which the 3000 or 5000 or 6000, sorry. They actually have 2 tubing ports, so they actually have a yellow and a green. And so the illustration was trying to say simplified. So if you have green tubing with your system, it would follow with the yellow. So one of the things that is a challenge, and there's lots of different theories about how to set up my red reference. So I am the operator, and I and my gauge are inside the structure, and I'm going to send my reference tube outside. And there's various ways in which I can actually follow different standards on how I would actually put it around the structure in general. But one of the things I'm going to do here is that I can actually combine them together. And depending on how you're doing your testing, which we had an illustration earlier, was that I actually would take my blue tube, which normally doesn't have anything on it when I do a residential test, and I can actually now combine these and send it to a specific location for all 3 fans. Or I could actually do the same. And this is an example of what happens when you actually do these large testing itself. So, oops. Or I actually have the option of sending each gauge off to a different floor or a different area, so that I can actually monitor them on each individual gauge as I'm doing my test. So how you set this up is incredibly sophisticated and gets way beyond what I can do for you in an hour. These are sometimes an entire day or most of a day class on some of the setups, again, depending on the standard that you're using. So on the bottom left here, you can see those are the older gauges and the monstrosity of umbilicals that were there. On the right, things get a little more simplified, and I'm able to actually leave the gauges near a central location or near the fans and run much longer Ethernet cables. One of the things I do want to mention when we're dealing with the basics is that power, that if you're going to have 3 fans, even 2 fans, that you really need a single circuit for each fan. Because if you're going to put 2 fans into one circuit, there's a high probability that you could blow that circuit, and then you're dealing with how do I reset that, or where else do I get power from? So again, you should always keep in mind that you want to make sure you have assessed all your power and that they're isolated, knowing that they're on individual circuits. All right, so we're going to go through kind of a scenario and combine some of the concepts we just put together. So I have my 4-story building, and I decide I'm going to set up my 2 fans on opposite ends of the first floor. So my scenario is I've got my individual gauges next to each set of bank of fans. And this is the control system that I'll be using, so that each individual gauge has got a Ethernet that goes to a hub, and it goes back to a router, and I can now find all of the gauges through the computer. The router is the missing key there. You need a router because it assigns all the individual gauges the number based upon the wiring that you're using. So if you just have a hub, you'll get lost. You definitely need a router in the process. You can have multiple hubs as long as they're all able to be combined into a router. All right, so now we're going to combine our exterior or reference tubes. Again, we're going to be inside the structure doing the test. This is a common scenario. Some people, again, this is a design theory in general. And the other one is now we're going to use the blue tubing, which is the input on the gauge, to now actually monitor different floors. I need to make sure that I'm getting a pressure difference between the lowest floor and the highest floor, and I need to be able to be monitoring that, as well as knowing that I am actually getting the pressure, my test pressure, whether it's 50 or 75 pascals, throughout the structure. So those things have to be monitored and confirmed that you actually are in compliance. I made this kind of a SketchUp model. We discussed this at our Seattle training. It's one of the things we talk about at other trainings. So I thought that one scenario here, which will repeat itself, is that I got a bank of 6 fans. And the challenge is that how do I get all of my pressures all the way up to the top floor? Because I'm going to use the stairwell as my ability to move the pressures throughout the structure. My ability to move the pressure throughout the stairwell is limited by the opening in the doorway on each side. So some other alternatives are to add a fan to what's called boost the pressure, which basically just means that I'm going to try and help that door opening and add another fan in there to help move pressure throughout the structure. It doesn't read anything. It's just, again, trying to make sure I have airflow and pressure throughout the structure. The other one is, with extreme safety cautions, is to actually open up different elevator shafts on different floors, again, to allow that air to move between the first floor or the upper floors or whatever your limitation is. So these are referred to as pinch points, and they can really limit. You could decide you can have 50 fans on the first floor. That doesn't mean you're going to be able to get all the pressure I need to for this test up on the upper floors without a strong pathway to do so. All right, the next one I want to talk about is a compartmentalization test. This is something that LEED does. This is actually, of all the tests, I feel this is actually has a much higher priority than just testing the entire skin of a structure, because I ultimately am testing the skin or the outer air barrier when I actually do this, but I'm going to do it on an individual basis. This is what allows me to control connections between units on each side, above and below, or floor to floor, to finding out where my smoke or fire issues are, or what other kind of contaminants may be actually moving throughout the structure or to my neighbor on each side. So I got the condo here in the middle, only to find out that my neighbor loves to smoke cigars on the right. The other neighbor on the left put in a 1200 CFM exhaust fan in his kitchen, and as all I do is actually smell the cigar smoke going from my neighbor on the left to the neighbor on the right. So this is actually a great test in order to determine how well your structure was really built on the interior. And this actually is where your energy reduction gets reduced as well. It becomes a much safer and much better IAQ environment. So on the left, in order to test the center unit, my goal is actually test the stairwell or the hallway and test the units on each side. And on the right, I have a floor-to-floor plan. So my goal is I have to be able to test the floor really above or below. We're going to assume that the stairwell is open to the outside as part of that scenario. So the next set of slides, this could be a unit. This will be unit to unit, but it also could be a floor-to-floor scenario. I thought that I'd try and visualize what neutral pressurization, some people call it a guarded test. We feel neutral pressurization is really the term that actually defines what it is we're doing. So I'm going to try to test the green unit, unit A, and some of the challenges that happen when I'm connected to another unit on its side. So I get my blower door going. I'm going to run it to 50 pascals. And I'm going to pressurize. You can do this in depressurization as long as both fans are moving the same direction. So I'm going to pressurize because I think the example is a lot clearer. So I have air that moves from unit A to unit B. This is my leakage to unit B. I must open or release some pressure in unit B in order to actually get readings or allow the air to continue to flow. Otherwise, if I don't have some kind of pressure release, a window cracked or the front door slightly open, then actually this will become a kind of a solid pressure barrier and no longer allows me to confirm what type of leakage I have off to the right. So again, if I allow some type of pressure relief window, then I'm actually able to read the real leakage that's actually happened in my unit A. Now, if I really want to try and find out what's the leakage between unit A to B or any other unit that's connected, now what I can actually do is actually add a blower door, close the window so I no longer have a major leak. And you can take it to 50 Pascal because the example works well. You can also set this up to test to 0 compared to the unit next door. So in this scenario, my goal is to just make sure you visualize that I have unit A at 50 Pascal, unit B at 50 Pascal. There's a neutral pressure between the connecting walls, could be floor. And at that point, I have now isolated unit B from unit A. So I can now subtract that measurement or figure out what it is I'm actually trying to measure on unit A, knowing that unit B is no longer part of that measurement. So now we have a little better illustrations to kind of go through that. So we're going to, again, go back to measuring our unit. Looks like it's ABC. We'll measure unit C. And we have illustrations to kind of show it in from the plan view and elevation view and a three-dimensional view. So again, the goal is here to start with pressurizing one unit. I must open, again, some type of pressure relief on the two side units that are next to that. Again, right now my stairwell is open all the way down to outside, so I'm able to get equal pressure throughout as though I'm actually outside in general. So both stairwells are wide open. So I do a blower door test, and I get 1200 CFM on this first unit. And now I want to find out is what is the real leakage to either to unit, so I can focus on those repairs, or to find out what is actually the leakage of this unit itself. This is a challenge in terms of code, in terms of like if I want to do a blower door, Do I include neighboring units, or am I able to neutralize or subtract neighboring units? So every municipality is kind of on the fence about which way they feel they should go. A lot of them just say it's one single test because it's one single fan and nobody has to get a second fan to do that. So it would be good if they give you the option as to which way you wanted to go. So again, I got 1200 CFM on unit C. And now I'm going to set up my blower door in the stairwell itself. All right. Again, it's connected all the way down to the opening on the outside roof or ground floor. The other side is now actually sealed off. So now what I'm able to do is pressurize the stairwell, neutralize between the stairwell and the unit. Again, I still actually have pressure relief on both sides, and now I'm down to 1100, so I can tell that I have 100 CFM between the common wall of the hallway and the unit. And we'll continue this. So now, depending on how small they are and in your fan, I can actually just now open the door and let air move into the unit on the right side. Again, I have a pressure relief on the other. You can tell this would be a challenge for an occupied structure in terms of asking somebody if I could open their door and let air blow through, and see if the neighbor also next to them could allow me to open a window. So it does have its logistic challenges, but this is the practicality of actually doing this, or you totally appreciate what happens when you actually have a floor to yourself to do this kind of testing. All right, so now I'm actually able to include or subtract the unit to the right. So now I'm down to 900 CFM. Again, I'll do it again in the unit on the left, and I'm down to 850. And if you really want to get into more in depth about what your leakage is, you do the upper and the lower. And most people feel like, oh, well, that the leakage that's above you is nothing compared to the side. And I totally contradict those findings in many tests that I've done, because the reality is that the chases that run through these structures are just massive. They are a huge leak in these multifamily structures that I may do fairly well with my common walls. But I'm finding that actually floor to floor is actually the disaster. It isn't really going through the floor; it's going through these chases that they're using for mechanical reasons, or the thermostat wire that's got a 1-inch opening that actually then goes to a 1-foot chase that goes all the way throughout the structure. Those are the disasters that are happening in the multifamily structures. This type of test is what's confirming that I have those. And you may find that there's a diagonal connection between two units. So I'm going to move on to FanTestic. And well, let me pause now. Are there any questions that we have or anything we want to address real quick?
I just wanted to make a small comment while people are thinking about it, if they have any better questions. In the diagram you showed there, I actually had that diagram made, so I take responsibility for it. When you pressurize the apartment next to the tested apartment, it doesn't actually matter if you have the windows open. So in this picture here, it shows the window open in, I don't know what that is, the second unit from the top. You don't actually have to do that, because all you're trying to do there is to create 50 pascals in the unit on the right, 50 pascals the unit on the left. So it doesn't matter if the air is leaking out of the unit on either side.
Yeah, I should have caught that. Thank you for pointing out. I'll correct those illustrations for you.
So I'm not sure why we put those open windows there.
Right, or why somebody has a hot plate that they're cooking on in the hallway, but okay.
Hey, hang on, that's the guy that's running the test.
Okay, all right. Okay, any other questions you guys see? Jay, see any questions, or Colin?
We have a detailed tubing diagram. It's really important that you get the tube set up exactly right, otherwise this test will drive you crazy. And in our multi-fan manual, we have a diagram in there that shows you exactly where all the tubes have to go. So if you don't put them that way, it won't work.
Thank you. All right, so I could spend more than an hour just on FanTestic, but I'm going to kind of move through and make sure people feel familiar with it and know that there is options here to use FanTestic that actually are free, and what you get when you actually pay for a pro version. So there's one difference that's really should be clear about what FanTestic does, and I'll be blunt. Both, I knew Colin's going to kill me. Both sets of software are, when you first look at them, are really overwhelming. Right, they really are. Whether you're going to use FanTestic, or are you going to use TechTite or TechLog? It's not like some app you have on your phone that's easy to use and intuitive. Both of these take a little bit of time to actually kind of dig in. They both have some great functions. FanTestic has some functions that make things very simplified for the average user, that it can go out and just find my gauges. I can set it up to do a specific test, and it will do that. And in fact, this is the only software that will just do a standard test. What I mean by standard test, that means I'm going to use Army Corps of Engineers test or ASTM E779 test. It will do that test, and it will not just log some data that I then plug in to have it evaluated as that standard. These are actually will run the complete Army Corps or ASTM standard or your European EN number test. That it actually is designed to make sure it tells you which way you're testing, that you're covering your fans, and it does the exact number of multi-point tests for your baseline and your test itself, and then your baseline again, and then says, okay, here's your results. So you're not actually trying to just log some data and then decide what you're going to use, or did I actually take enough points to do that? It just does the test for you and does give you some flexibility. So I left this up here so you guys could see. You can go to retrotech.com if you want to download FanTestic Lite. It allows you to test one fan and one basic standard. You cannot do any kind of Excel or Word after, I believe you have 30, 60 days. You can actually do a lot with the Lite version, and it says, sorry, your time is up, but you can still use it, right? Which is a really great feature. If you want to upgrade to Pro, then you can now have two fans and one standard, or many people that do this regularly are the 6 or 24 and have a full gamut of access to report writing or Excel printouts. So again, if you're not used to it, it feels overwhelming. I can tell you for somebody who doesn't use it every day that I can still open it up and tell it to find my gauges, pick the standard I want to do, and tell it to start test, and it begins its test. So those are all great, great simple features for this type of software.
Joe, I just want to make a point about FanTestic. If you get FanTestic and you know absolutely nothing and you say, I want to test to EN 13829 in Belgium or in France, or I want to test to the Army Corps standard in the US, and you set the fans up and make sure you can get the pressures you want, and if you press auto test, it basically does the auto test according, fully compliant with that standard. You don't have to read the standard or anything. It will do that test in full compliance with the standard and will tell you at the end of it whether there was something that was not in compliance. And you essentially don't have to know anything in order to be compliant to any one of the, I think we have 15 standards listed in there. And I think that's a very important feature that FanTestic offers.
So one of the things that people should make sure they have is their software is up to date. FanTestic also, like many other software applications, updates regularly. Sometimes people use it in the field and they're not online, and then don't really go back home and open it enough to find out that there's an update. So it does check itself for updates, but only if it's also online. So it's important that you do open it up when you have an internet connection, and it will determine if you need an update or not.
So that's a very important point. We probably release a new copy every 2 weeks or so, and you do have to ask for an update. If you ever refuse the update, then it will never ask you again until you ask for it. A couple of people said that they were having problems with getting agreement, or they had some questions about it. If you have a problem with the software, don't call support and say, the software is not working, what do I need to do? Send a copy of the data file and our software manual that you can click on when you're operating FanTestic under, I think there's a support thing. We'll actually show you the manual, or you can download it from our website. The manual will show you how to send the information to support so they can actually solve your problem. It's very difficult for them to solve the problem if they don't have the data file. So there's the data file, and when they see that, what they can do is they can click on it, they can open up your test, and they can see exactly what you're seeing on your computer. If you don't send them that, then you'll go around and around in circles. They'll probably ask you for that anyway. So that's what I would ask you to do if you need a support on our software.
Thanks. So Cohen said it sounds like it's very intuitive. I kind of also refer to things as fail resistant. So, but again, like many other software, it does take some attention and in making sure you do understand some of the options that are on there. And you can just press, start test for the standard you want, and 9 times out of 10 it will actually just be able to complete that entire test as long as you checked the range of what that test is. So if you're going to go from 20 pascals to 75 pascals, I do need to make sure that I've confirmed that I can actually reach those test pressures with the fans I'm using in the same scenario. So I know they're not battling at a certain point, or I don't have to pause and change ranges. Or if I do, I need to know that so I can actually make sure I plan accordingly. So that's definitely one key as to part of that. And as many people point out, that many of us live with Microsoft products, from Office and version 10 or 11 or whatever it is that we have on our computer, and all those things are constantly having challenges and updates. So I think if you have software in your life, then you must realize there must be some small glitch to always constantly overcome, or keep track of all the different parameters are out there with all the different PCs. So a few of the things that it does do, I'll get back on track here. So it automatically can find your gauges and connect to those. And as you can see here, I actually have this top gauge, which is the 400094 gauge. And that's actually the one that would be my master one. That's actually the one that I'm actually designing as how it's going to reference outside. And you can determine which one of those gauges is assigned to that. The feature that I like the most is that all of that information that's on the software can be overwhelming, and I can actually hide any section that I don't really need. Like I don't need the application info with the picture of the house, or I don't need their summary until I actually want to open that. So I mostly can leave the equipment and the pressurization test running, and just kind of focus on what I need to when I run the test.
Another quick one, a couple of questions here. It's not just enough to update your software. You have to update your gauge as well. The DM2 you could not update, but the DM32 you need to update the gauge and the way it communicates. So you can do that as Joe described earlier in the webinar. So both of them need to be updated.
Someone asks us, can I use the DG700? And you can. There's actually an adapter. I kind of had a slide that showed that earlier, that you can get the adapter and so let me correct it. You can actually, with the Minneapolis fans, you can't use it with the DG700. So that's actually, those are proprietary to each manufacturer. But obviously, you must have Minneapolis fans. So some people are doing these tests and are like, I need 8 fans. I can now actually use a combination of RetroTech and Minneapolis and still use FanTestic software.
You can enter the data manually from the DG700 into the software and it will still work, but it won't take the data off the gauge automatically.
Yeah. So one thing you can do, which is a great feature, depending on what your application is, or some people are trying to do diagnostics at a certain structure, or you don't want to just run an entire ASTM 779 test, you can actually evaluate and determine and alter the parameters. Like I can decide to just take one baseline for 2 seconds and move past that because I don't need that for the diagnostics or the study that I'm doing on this structure. I may just need to see if it's going to respond a certain way. So you have a total control over all the parameters, how many pressure points it'll take for its baseline and for how long, and for each one of its tests. And all that stuff is totally controllable. And you actually have the ability to create your own standard if you needed to do a specific type of study.
So we've idealized the setup parameters for each standard, like in France, for example, where they want flow at 4 pascals. We've specifically taken a different pressure range than we do for people that want results at 75 pascals. And if you follow that range first, like the range that we put in there as the defaults, it will work well. You might want to increase some of the times if you have a particularly windy day, but I would suggest you start at the defaults. And again, if you don't know anything, it'll probably work fine. And if you go in there and fiddle with it and it's not working and you want to go back, you can always reset to standard defaults up on the top left-hand corner there. Back to you, Joe.
Great, thank you. So there's some amazing analytical tools. I know that Cullen's like wants to jump right back in, but they just recently added some of these abilities to actually see the points and plot them on a graph, and I have a better scenario. So I'm sure, Cullen, you can't not hold back on what you would do with this kind of data now that we have it. That's your clue. That's your cue. He must have his mic off. So
sure, you have even the most updated one.
Yeah.
Can you hear me now?
Yes, go ahead.
Yeah, I don't think even on your slide there you have the most updated one. The most updated one will take every single point, and you can see it plotting data as you go. The one that you're showing there is one that you see after you've taken all the data. So if you play around with it, you will see these features pop up. They're pretty easy to follow.
I do have custom reports, but my image did not work. So trust me that the custom reports mean that you can actually create a report when you buy the pro versions and are able to make sure you not just have your own personal information or your own, graphics, but the report is based upon that standard, so that you don't have a bunch of information that I really didn't need to do an ASTM test or the Army Corps test. All of the reports are designed to actually fit the standard itself in the chronological order, and they're customizable. So if you're like, well, I don't really need this, or I want something to the language to be different, you can actually go in and actually change that. There's a couple other bits of software I'll move through quickly here, and that is there's a data logger. Again, this is free. It works with the DM2 and the DM32, and basically it will just log the data as it runs through the gauge. And it can do multiple gauges. So if you're doing, multifamily, or we talked about doing the compartmentalization, this is a phenomenal, simple tool to actually, I just want to see the data because I'm going to control the fans myself. So I can also do this on the Wi-Fi because the areas are small. And basically you're going to hit start, and it will run. And when it's done, I open up an Excel spreadsheet. And so here I had 4 DM32s with their serial number, what device they were, what kind of range they were on, and the pressures and the flow. So I can actually see all those scenarios. So you can see in the beginning, I didn't have any readings on the first few rows, and then you can see the readings start to pour in. So this actually is an amazing resource. Also determine if I changed the range or if I did something else, the gauge will remind me if we did that, and it'll be recorded in the data logger. Okay, so there are enormous amount of other opportunities that are out there. This is where Cullen thrives, and I have an overview, and I have an individual slide for you, Cullen, about each one of these. So I'll just kind of let it roll and let you go. You're on, Cullen.
Okay, there I am. I just unmuted myself. So I guess you're going to be advancing the slides for me. That's
sure.
Cool.
Okay.
If you have even one blower door, there are a huge number of extremely profitable testing that you can do. And when we do a pressurized stairwell, we do them for the local utility that has hydro dams and this and that, and they'll put a pressurization system in there. And the question is, well, gee, how much flow do I need? They have no idea. 10,000, 5,000 CFM, whatever. So I come along with my blower door, I turn it up to the test pressure that they want, which is usually about 50 pascals or so. Sometimes it's 25. And I say, well, you need 2,500 CFM. And they say, thank you very much. And that's what they buy, and they install it, and everything is fine. Those tests take us about an hour or two on site and an hour to write a report. And we charge them about $3,000 for that test, and they're happy to pay it. The other choice they have of just buying an oversized blower will cost them 10 times that. So that would be the first one. Be in touch with the local industries around you, and a lot of this actually relates back to one of the applications that we have a whole lot of slides later on, what we call enclosure integrity testing. What enclosure integrity testing is determining how tight a room is inside a building that is being protected with a clean agent gas, which used to be halon, is sometimes CO2, can be an inert gas like argon or argonite, which is a mixture of nitrogen and argon. or it can be nitrogen and so on. And these extinguishing systems are very powerful, and they're called clean because there's no sprinklers and they don't make a big mess. And then when the fire is over, you just open the door and air it out and you're done basically. So a lot of this information, actually, there we go there. A lot of this information that we have comes from many years of working in what we call the enclosure integrity testing market, which is actually a huge market for us. I am the resident expert worldwide on this particular topic. I've written the NFPA standard and the ISO standard, and I maintain them. And I'm the guy that all of the main manufacturers go to if they ever have a question about the enclosure when it comes to containing these agents. Most people can actually get into this business locally, and you can even find out to what extent there may be an opportunity in your area to contact the local fire suppression companies and ask them if they sell clean agents and if they do enclosure integrity testing. There's been a new addition to the NFPA standard, which is used in probably half the countries of the world, where they now require the installation of pressure relief vents. I'm not sure if you have a picture of that. I don't see one in here.
I do not.
And they kind of don't know about that, and so it's a big question mark for them. The opportunity is one where the fire suppression company makes its business installing tanks and pipes and control panels and so on. Average installation cost of one of these things is about, maybe $150,000, $200,000, that kind of thing. So a few $1,000s worth of testing is actually not all that big a deal, and it's actually required. So if you can back up to, say, UFAD testing, which is about 6 or 7 slides back.
Yeah, maybe we stay on the path here.
Yeah.
Let's talk about what's on the slide. Okay, great.
So UFAD testing is underfloor testing, underfloor access design testing, and this is one of our customers in Seattle that has pioneered the testing of that in their area, and it's an up-and-coming application. Air conditioning systems are pumped into these subfloor zones, and they want to make sure they're properly contained, and this is how they do it, by taking one of our blower doors and pressurizing the floor. It's actually a pretty simple test to do. So it's something that's definitely worth looking into if you start working on these larger commercial buildings. It's not just a matter of testing the whole building for leakage. There's all kinds of other sub-tests that you can do, and UFAD is one of them. The next one we have here is elevator shaft testing, which in some cases is a required test. So you can see that with pressurized stairwells, underfloor testing, elevator shaft testing, enclosure integrity testing. Then we go to the next slide, critical care. The next one is areas of refuge. You may be able to do several tests in the same commercial building. So what I want to do is I want to open up your eyes to a bunch of opportunities. The next one is rain penetration testing, and here they have a rain grid that's squirting water onto a window, and they take one of our blower doors, they stick it into a door panel. The blower door that they typically use is the 3000, now called the 6000, and they use that because it has a variable frequency drive, and it has 1.5 horsepower, and it likes high pressure. House testing fans, the 1000, the 2000, and now the new one, the 3000 or the 5000, are designed for testing houses, and they tend to, it's like the difference between, say, a Volkswagen and a gravel truck. A gravel truck is can't really go any faster than the Volkswagen, but it hauls the heavy loads. So the high power fans we have, and you can see down here in this picture, there's a variable frequency drive sitting on the floor, are designed for this high pressure. Typically, these tests will be done at 150 or 300 pascals, negatively pressurize the apartment, the office, the unit, whatever, and then when the rain grid is squirting on the windows, you go inside and see where the rain penetration was. And the slide that I created, I put the standard number, I think it's 1107 or whatever. This is a smaller version of a window test where you're actually measuring the leakage of a window, covering it in plastic and sealing it with the red tuck tape and so on. this little duct tester will go down to a few 100ths of a CFM, so it will literally measure pinholes. So you can take components like this and measure them. So we've gone from potentially looking at energy problems in a building to a whole series of tests that you can do in the same building, including in the next slide. There are companies that actually use blower doors to test roof membranes, and one company actually uses a blower door to lift up the roof membrane so it's 3 or 4 feet above the deck, and then crawl around inside and find out what's going on. I know nothing about this application except I just want you to be aware that it's out there, and people that understand roofs might might want to hire you to do that, or hire you to use your equipment and so on. We do have a past webinar that's called what's that webinar called, Joe? Tests for equipment you already own or something?
Yeah, right, something like that. What else can you
It's
do
on
with
our
the equipment?
webinar list. If you go to our webinars, in the top right hand, there's a little button that says past webinars. Click on that, and there's about 50 webinars in there. Quite a great library of information, and there's one there for doing tests with equipment you already own, and that's one of them.
So, everybody, thanks. Have a great day.
Bye, Joe.